In this lesson, I'm going to try to show you the graphs of the sine and cosine functions. I basically want you to learn just basic conceptual ways of figuring out what the graph looks like. I know there's a technology that you can use for this, but I think there's great value in knowing how to do it by hand or being able to see a graph and noticing which one it is. Let's begin to talk about what these graphs are. They are periodic functions, and a periodic function is a function that looks like this, where the function repeats every certain amount of values, which is called the period. So the least positive value of p in this notation is the period of the function. The basic period for our sines and cosines, these circular functions, is 2 pi. So the least value for which the sine and cosine functions repeat will therefore be 2 pi. So let's just summarize this. The sine and cosine functions are periodic functions with period 2 pi. And so in place of that p in the generic formula here, we're just going to put 2 pi there for both the sine and the cosine. And if you remember from your unit circle, the values of the sine and the cosine functions alternate between -1 and 1, okay? And we're going to use that to our advantage to be able to graph our functions. And so the sine function begins at 0 and it increases from 0 to 1. Then it decreases from 1 to 0. And we'll have a look at a picture right now so you can better understand this in case you don't have the unit circle handy there with you. Then it'll decrease from 0 to -1, and then it finally increases back from -1 to 0. Okay, and these are the intervals that it goes through. The cosine is a little different. The cosine, in fact, it's off by pi halves. It's off as far as comparing to sine. So it's cosine starts at 0. The cosine of 0 is 1, and it decreases from 1 to 0. Then it keeps decreasing from 0 to -1. Then it increases from -1 to 0, and then it keeps on increasing from 0 to 1. Okay, and you can see that if we start after pi halves and we look at the values starting at pi halves, that's the beginning of cosine over here. So they're off phase by pi halves. Okay, let's look now at one of the graphs here, the graph of sine. As you can see here, it does alternate between -1, so a max of 1 and a min of -1, and it has a period of 2 pi. So like from here, if you follow the pen all the way to 2 pi, that's 1 period, and then it repeats and it keeps on going indefinitely. And that's why its domain is from -infinity to infinity. And its range is between -1 and 1 inclusive. And then you can get certain values. These values, you can get them directly from the unit circle if you wanted to. So for every x value, its corresponding y value would be this. So 0, 1/2, the square root of 2 over 2, the square root of 3 over 3. At pi halves is 1, at pi is 0, at 3 pi halves is -1, and at 2 pi is 0. Okay. This graph is continuous over its entire domain, and its domain is like we said earlier, -infinity to infinity. Its x-intercepts have values of the form n times pi, where n is an integer. X-intercepts means where it crosses the x-axis, and you can see it cross at pi, at 2 pi. It would cross at 3 pi, over here at -pi, -2 pi. So at integer values of pi are its x-intercepts. Its period is 2 pi. The graph, this sine graph, is symmetric with respect to the origin. So any graph that's symmetric with respect to the origin is called an odd function. And that means that for all x in the domain, the sine of -x will equal the negative sine of x. Okay. And remember, this sine function is related to the unit circle. So its domain consists of real numbers corresponding to the angle measure. So its domain corresponding to the angle measure in the unit circle, and its range corresponds to the y coordinate on the unit circle. Let's look now at the cosine graph. Very similar in as the sine, except remember I told you this one's off phase by a value of pi half units. So that's what we have up here. The graph of the cosine function is the graph of the sine function shifted or translated to the left by pi half units. Okay, it still has the same domain and has the same range. Okay, and we can come up with these values once again from the unit circle. The cosine of 0 is 1. The cosine of pi halves would be square root of 3 over 2. The cosine of pi fourths would be the square root of 2 over 2. Pi thirds would be 1/2. Pi halves would be 0, and then -1, 0, and 1. This graph is also continuous over its entire domain. And the x-intercepts are a little bit different. Remember, they're off by pi halves. So it's at values of pi halves. So we would write 2n plus 1 times pi halves, where n is an integer. Its period is still 2 pi. This graph, however, is symmetric about the y-axis. Remember, the sine graph is symmetric about the origin. So symmetry about the y-axis means this is an even function. And an even function means that for all x in the domain, the cosine of -x is equivalent to the cosine of x. Okay? So no matter if the x is positive or negative, they're going to have the same y value, the same cosine value. Okay? All right, let's attempt now to graph this function where there's an amplitude involved. The amplitude is a number in front of the value of the sine. So graph y equals 2 sine x and compare to the graph of y equals sine x. So I'm going to make a table here where I'm going to have the x values. Then I'm going to have the sine values of that, and then 2 sine x values. Okay, let me just And I hope that with practice, you'll be able to do this and without the need to reach for anything to do it for you. So, and I want to write out enough of these values where one period happens of the graph. Since its period is 2 pi, right? Then I broke this up into 4 intervals. They look like 5 because of the 0, but the 0 kind of doesn't count. Okay, so if you follow my pen here, so from 0 to pi halves is 1 interval, and then from pi halves to pi is another interval. From pi to 3 pi halves is a third interval, and then from 3 pi halves to 2 pi is the fourth interval. It's very important that you know how to break up based on the period into 4 intervals, and it's just arithmetic. So I hope you get the hang of it. So the sine of 0 would be 0. The sine of pi halves is 1. The sine of pi is 0. The sine of 3 pi halves is -1. And the sine of 2 pi is 0. So it completes the period right there. And then for 2 sine x, you just double every value in that list. So that's 0, 2, 0, -2, and 0. Okay. And so this top value here, those are your x values. And then this bottom value, these are your y values. So let me write that out one time so that you know what I'm doing, and hopefully you catch on. For the interest of time, I won't be writing them all the time, but these are the points I'm gonna plot now, right? So it's gonna be 0, 0, and then pi halves 2, 0, 0. I'm sorry, pi half 0. I already have 0, 0. Pi halves 0. 3 pi halves -2. And then the last point I have there is 2 pi 0. So those are the points that I'm gonna plot so that I can graph my this function here. So here we go. Let's see, 0, 0. Pi halves 2. So pi halves 2. Pi halves 0. 3 pi halves -2. And 2 pi halves 0. And then you draw a smooth curve of the sine function and do it as smooth as you can. Mine's not as smooth as I used to make it because I'm not as sure-handed as I used to be. But there's your sine function. Notice from here to here is an amplitude of 2. And whereas to compare it to the graph of just the regular sine function, well, the regular sine function would have had an amplitude of 1 right there. And so it would go there and then here, right? So let me draw it with a tick mark right here. That's what the regular sine function will look like. So this function, y equals 2 sine x, has been stretched vertically, like it's pulled vertically, right? We call that vertical stretching in mathematics. And we can think of the graph of y equals a sine x as a vertical stretching of the graph of y equals sine x. When a is greater than 1, and a vertical shrinking when it's between 0 and 1. And again, we don't have time to do the between 0 and 1, but you can test that on your own in using some technology or taking some time to do it. You would come up with the points just that way, right? You know, like if instead of that 2, it was 1/2, then then our new one would have amplitude of 1/2. So it would be like a, between the original and the x-axis. But that's called vertical stretching, this one. If it had been shrunk down, then it would have been called vertical shrinking. All right, let's look at the next one now. What if the 2 is inside of the function, right? This 2 used to be outside. What if it's inside? Let me get my paper a little better here. You still do it the same way, except if the 2 is inside, that's going to affect the period of the graph. Okay, if it's just x inside of the argument of the function, the period's always 2 pi. And so if I call this sine bx, then the period of that specific graph would be 2 pi divided by b. And so for this one, the period then for this specific graph would be 2 pi divided by 2, which means it's pi. And so now the graph that I'm gonna graph would repeat in intervals of pi. So my new graph, instead of going between 0 and 2 pi, will now go between 0 and pi. And just like in the other graph, I want to have 4 intervals, right? And my intervals, so 4 intervals, right? My intervals are these. So between 0 and pi, I just broke them up into 4s. So pi 4s, pi halves, 3/4, and pi. You're still gonna get the same values for the max and the min and the zeros, right? Except now at so at the cosine the sine of 0 is still 0, right? But the sine of pi fourths now is equivalent to the sine of pi halves, because when I plug in pi fourths there, 2 times pi fourths is pi halves, and the sine of pi halves is 1. So now that value of 1 is at pi fourths, right? And then the rest continues that way at those intervals. So like that. And if you wanted to, you could extend the graph this way if you wanted to. Just it's just follow the symmetry there. So like at negative pi fourths, it would be at -1, and then 0 here, and then +1 over here, and then at negative pi would be 0. Okay, and you can see there, it's the repetition of the sine graph. But now again, this one has a different period. The period is pi, so you translate to 4 different intervals, and you continue to graph it. Okay, we can think of the graph of y equals sine bx as a horizontal stretching of the graph of y equals sine x when b is between 0 and 1. Okay, and a horizontal shrinking when b is greater than 1. Okay. So the key is finding the new period, and then getting that broken up into 4 intervals of equal length, right? So between 0 and pi, that whole interval has a distance of pi. So divide that by 4s. That means each one would be pi 4s, and then you figure out the corresponding values. If we look at this one here, the cosine of 2/3 x, then we would have The B value for this one is 2/3. And so the period is 2 pi divided by 2/3. And if you divide that, the 2/3 flips over and you get 6 pi halves, which is 3 pi. So that's our new period. And that means our interval that we're going to graph is between 0 and 3 pi. And then divide those into the 4 intervals. And therefore, our x values would be 0, and then 3 pi fourths, then 3 pi halves, then 9 pi fourths, and then finally 3 pi. And remember, at those values is where you're going to get the max and min and x-intercepts for the cosine function, right? So the cosine of 2/3 x at these values is where the original the 1, 0, -1, 0, 1 values coincided, right? So then those will be 1, 0, -1, 0, and 1. And those are the points I would graph here now. So at 0, 1 first. Then 3 pi fourths, 0. 3 pi halves, -1. Then 9 pi fourths, 0. And 3 pi halves, 1. Okay, and remember, it's a smooth curve. It's not a V. It's a smooth curve like you saw originally. There's your curve, and again, we're only drawing one period, right? Obviously, it continues as you go along. All right, let's do some generalizations now. Here's some guidelines for sketching the graphs. You find the period. And again, you sketch the graphs if there's a B value inside that's not 1. The ones we started at the beginning, those were 1. So we didn't have to do, we knew the period was 2 pi. So you find the period by taking 2 pi and divide that by B. You start in the 0 axis, and then you go all the way to that whatever that value is, to 2 pi divided by B, right? Just like in this last one, I went all the way to 3 pi. Divide the interval into 4 equal parts. Evaluate the function for each of the 5 x values resulting from step 2. These are the x values that we're discussing in this problem, right? In this generalization, like those 5x, and then those 5x values will coincide with the ones, the 0 and the -1. The points will be the maximum, will be maximum points. Minimum points, right? The -1. So the 1, the -1s, and intercepts, which are zeros. You would then plot the points and join them with a sinusoidal curve having amplitude. Whatever, if there's a value of A, that's the amplitude, but sometimes it might be negative, so let's put the absolute value of A. And then if you need to, you can draw the graph over additional periods, okay? But usually you just want to know what it looks like in a certain period. All right, let's look at this one here. So this is just in general. So -2 sine 3x. So the B value for this one is 3. So the period is 2 pi divided by 3. Okay, so our interval of our period will be between 0 and 2 pi thirds. right? Between 0 and 2 pi thirds. So you're going to divide these into four equal intervals. So you're going to take 2 pi thirds and divide that by 4, right? And if you divide that by 4, that would be 2 pi 12s, which is pi over 6. Okay. And so your x values that we're going to use to plot here, you start at 0, then you go in intervals of pi over 6. So pi 6, and then pi thirds, and then pi halves, and then 2 pi thirds. And that'll be the 4 intervals. Again, there's 5 values because the 0 kind of doesn't count. And then if you have to, I would say, like I made a table at the beginning, you make a table for this. So like for x, for 3x, for sine of 3x, and then finally for -2 sine of 3x. Okay, so let me draw this out. So 0, pi over 6, pi over 3, and then pi halves, and then the last one is 2 pi thirds. Okay, and so remember, when you triple these, they become 0. This becomes pi halves. And remember, we did this on purpose because these values that we're going to get are going to be those max, min, or intercept values. And so this is, when you triple pi thirds, that's pi. This is 3 pi halves. And then this will be 2 pi. And then you take the sine of those values here. That will be 0, 1, 0, -1, and 0. And then finally, this one's the one we're going to use for our graph. Is -2 times that. So 0, -2, 0, 2, and 0. Okay. So these are my x values up here, and these will be my y values. And that's what I'm going to use to plot this here. So 0, 0. And then pi 6, -2. So at pi 6, I'm at -2. And then pi thirds, 0. Pi halves, +2. And then 2 pi thirds, 0. And then you can see the curve there. I went a little bit off up there on top. And I lost my balance with my hand here. But that's what it looks like. And of course, you can add more periods if needed, you know. That's what step 5 is, that you can just repeat the period again and you know, keep doing it, you know, with more intervals. I hope you got a decent understanding about how to sketch the sine and the cosine curves.